everyone. Today I'll teach you how to solve this problem. This problem is from a high schooler. She asked me help her to solve this problem. The problem is the line AB has the equation 3x plus 4y minus 15 equals 0. The point O is origin. Then they ask you solve these two problems. Under these two big problems, we have another three small problems. The first small problem is what is the coordinates of point A and B? To find coordinates of point A and point B is very easy. You just need set x equals 0, then plug to this equation. Then we can get 4y minus 15 equals 0. Then that means y equals 15 over 4. By this way, we get the A coordinate, that's 0, 15 over 4. To find coordinate of B, we just need to plug y equals 0 to this equation. We can get 3x minus 15 equals 0. That means x equals 5. So then coordinate of B, that's 5, 0. So by this way, we solve the first small problems. Then let's go to the second small problem. That's find the area of the triangle OAB. To find the area of triangle OAB, you know this is a right triangle because S is OX perpendicular to OY. Then the right triangle area, so that's S, triangle OAB, that's equals 1/2 times length of OB times length of OA. Right? So length of OB, that's 5. We already get this. Length of OA, that's 15 over 4. So then we can simplify this, got 75 over 8. This second one. Then third small problem is find the length AB. Length of AB, this is hypotenuse of right triangle OAB. To calculate this hypotenuse, we just need use these two legs, square that, say length of AB equals length of OA, square it plus length of OB, square it, then square root. Length of OA, that's 15 over 4, square it, plus OB, that's 5, then square it, then square root. You get this one is 225 over 16, then plus 25, then square root, and get this one. That's 225 plus 400 over 16, then square root, and this one gives us 625 over 16 square root, that's 25 over 4. Right? This is length of AB. Okay, then we solve the first big problem, A. Then let's go to second big problem, B. In the B, the first small problem asks you the non-OC. They tell you non-OC is perpendicular with line AB, and they ask you find the length of OC. To find length of OC, we need to know what is the coordinate of C first. To do that, we need to find the line equation OC. To find the line equation OC, we need to know the slope of OC. but OC and OB perpendicular to each other, right? So then the multiplication of slope of these two lines should equals -1. From this line equation, we got the slope of line AB. We can write that's 4y equals -3x plus 15. Then both sides divided by 4, we get a y equals -3 over 4x plus 15 over 4. So this one, -3 over 4, is the slope of line AB. Then by this way, we can get the slope of OC, that will be 4 over 3. Then this line equation will equals y equals 4 over 3 times x. This is equation of line OC, because OC passed through the origin, so the y intersection is 0. Then the slope of this line times the slope of this line equals -1. So that's give us 4 over 3, the slope of this line. So then by solve these two equations, we can get the coordinate of C. To do that, let's prop this equation to here. We get 4 over 3x equals -3 over 4x, then plus 15 over 4. Then let's times 12, both sides, we can get 16x minus 9x, then plus 45. So that means 25x equals 45, so x equals 9 over 5. That's x coordinate of C. Then prop this one to here, we can get a y coordinate, that's equals 4 over 3 times 9 over 5. So that's give us 12 over 5. That's y coordinate of C. Okay, now we can calculate nuts of OC, right? Nuts of OC, two ways. One way, you can just use the distance between C and O. So that's 9 over 5 minus 0, square that, plus 12 over 5 minus 0, square that, square root. So this gives us 81 over 25 plus 144 over 25, then square root. So it's 225 over 25 square root. That's give us 15 over 5. So that's equal to 3. This is one way. Another way, you can, this one, OAC is a right triangle. And OA is hypotenuse. The OC and AC is two legs. To calculate nuts of OC, we can do OA square that minus AC. But we don't know AC yet, right? This one square root. OA we already know, that's 15 over 4. Then this one squared. AC you need to use this one minus this one. So minus C. So to do that, first we need to calculate that's actually it's a third one, AC. So let's go calculate this one in the third problem. Let's do that later, okay? The second one is area of triangle OCB. OCB, this is also a right triangle, right? And also you have two ways. One way you can use OC times CB then divide by 2. But we still don't know how long is BC yet, right? But we know OB and the height. Height actually is y coordinate of C, so we can do this way. So area of triangle OCB, this one equals 1/2 times nuts of OB, then times nuts of height. let's use h to represent the y-coordinate of c. So then we get a 1/2 times 5 times 12 over 5. So then we can get this one equals 6. So then we solve the second one. Then let's go to the third one. Find the nuts of AC. Find nuts of AC is very easy. AC will equals 9 over 5 minus 0, then square it, plus 12 over 5 minus 15 over 4, then square that, then square root. So this one gives us 91 over 25, then plus, we can do this one, that's 20, this one 48 minus 75, then this one squared, right? So then square root. So continue 81 over 25, then plus, this one give us 27 over 20, then square it, then square root. So you can solve this one. That will be this 400 divided by 25, that's 16. So 81 times 16, that's 6, 48, 1, 8, no, that's 6, 9, 12, right? This one, that's 27 square, 27 square it, 7 times 49, 14, that's 18, 14, 5, so that's 9, 12, 7, add here, 7 to 9, that's 5, 2, that's 0, 2, 225, 225, then square root. So the under that's can take out, that's 20, 2025, 225, let's divide by 5 first, 405. 405 divided by 5, again, that's 81. So then let's give us 5 times 9. So then this one, 9 over 4. So give us 9 over 4. This one is answer. So this is nut of AC. So that's all for today. Thank you for watching the video. See you next time. Bye.